The Mars 2020 mission includes the helicopter named Ingenuity. If successful, it will be the first powered aircraft to fly on another planet. The name Ingenuity was selected from the Name the Rover competition entry submitted by Vanessa Rupani from Tuscaloosa County High School in Northport, Alabama. The mission also includes the Perseverance rover, which will search for signs that Mars may have once supported life. The rover will also perform a number of experiments and collect data to prepare for future human exploration of the Red Planet. In this video, you will learn how to solve problems involving mass, force, and acceleration using Newton's second law, F equals ma. The SI unit of force is the Newton, named in honor of Sir Isaac Newton, whose book Mathematical Principles of Natural Philosophy laid the groundwork for classical mechanics. A Newton is a derived unit equal to 1 kilogram meter per second squared. For the first example, we'll calculate the gravitational force exerted on Ingenuity while it was on Earth during development and initial testing. Let's start by identifying the variables in this problem. The mass of the helicopter is 1.8 kilograms, and the acceleration of gravity on Earth is 9.8 meters per second squared. Force is the unknown variable in the problem. To solve for force, you can use the problem-solving circle by covering the variable you are solving for. In this case, that is force. Let's cover the F with the Earth, since we are solving a problem about the force of gravity on Earth. Using this technique allows us to solve that force equals mass times acceleration. Our next step is to insert the known variables into the equation. Let's set this up using dimensional analysis to see what happens to the units in the calculation. The mass was 1.8 kilograms. Let's write that over 1. Next comes the acceleration of gravity, 9.8 meters per second squared. You want to write that as 9.8 m over s squared. This helps us to see that the answer is 18 kilogram meters per second squared, which converts to 18 newtons. Our second problem will involve calculating the acceleration of gravity on Mars. So let's start by identifying the variables. The mass of Ingenuity is 1.8 kilograms, and the gravitational force Mars will exert on the helicopter is 6.68 newtons. We want to calculate the acceleration. Covering the A in the problem-solving circle allows us to determine that acceleration equals force divided by mass. Remember that you can use the problem-solving circle and simply cover the unknown variable to reveal the equation used to solve for the unknown. To solve, we will use a dimensional analysis setup. A equals 6.68 kilogram meters over second squared divided by 1.8 kilograms. The answer is 3.7 meters per second squared. Notice how the units of kg will cross-cancel to give the appropriate units of meters per second squared, which is the units for acceleration. When JPL was testing Ingenuity on Earth, they basically used a fancy fishing line pulling up on Ingenuity. The upward pull of the line provided a gravity offset, allowing engineers to simulate the strength of the Martian gravity here on Earth. The line needed to provide a constant upward pull with a force of 11.3 newtons to reduce the normal Earth gravitational force of 18 newtons to the 6.7 newtons the helicopter will experience on Mars. For one final problem, let's calculate the mass of the Perseverance rover. We'll start by identifying the known and unknown variables. The gravitational force Mars will exert on the rover is 3,805 newtons, and the acceleration of gravity on Mars is 3.711 meters per second squared. The mass of the rover is the unknown variable. We can solve Newton's second law for mass by covering the m. This shows us that we will need to divide force by acceleration in order to calculate the mass. So we have 3,805 kilogram meters per second squared. I'm using the full units for force rather than newtons here, so that later we can identify that the units for our answer check out. The force is divided by the acceleration of 3.71 meters per second squared. Notice how using dimensional analysis makes us put the m in the denominator and second squared in the numerator. This helps us to see that the second squared units will cancel, and the m units will also cancel, leaving only units of kilograms. We find an answer of 1,025 kilograms. Thank you for watching. I hope you found this video informative and helpful. If you did, please consider giving it a like and leaving a note or a question for me in the comments. And don't forget to subscribe and ring the bell if you want to keep up with all the new videos I'm posting about the Mars 2020 mission and other cool science stuff. Until next time, stay curious.